Thank you, everyone, and welcome. I'm Omer, and I'm the VP of Research and Development at Sysdig. Sysdig is a container and security company. And what I'm going to try and answer today is where are all of the container breaches? Now, to understand why we're even asking the question, I'm going to go back a bit. In about 2018, I joined Sysdig, and one of the things that we wanted to do as a company is to better protect container users. So the first question we ask is protect from what? You see, there's not a lot of data and information out there about container breaches. So what we've done is to really embark on a research initiative to go and uncover sophisticated container attacks and try and really find a solution for those attacks. So we cherry-picked containerized applications, and we make sure that they're misconfigured, they had weaknesses, and so on. And we deploy them around our honeypot networks across the globe, across regions, cloud accounts, on-prem, opened them up to the world, and made sure that we record every system activity. And then we waited, and we waited, and we waited. And you know what we saw? Nothing. Not really nothing. What we saw is benign application attacks. The same old things that we used to see in the past, SQL injections, attempt to exploit Java applications. Some of them actually landed within the container, but nothing really interesting happened. No one really tried to bypass the container subsystem or really steal information. There was nothing. So our first reaction was, wait a second, any chance that containers solved the security problem? And our immediate reaction to that was, no way. It's too good to be true. There's no way that containers are so safe. So the second thing we asked, are companies really using containers out there? Maybe they're not an interesting attack target. So we started this journey about figuring out where are all the container breaches. And our first point was to figure out how companies are using containers out there. And what we discovered by asking a lot of organizations is that containers had a profound impact on the way companies conduct their business. And the reason for that is pretty simple. You know, in the past, if you wanted to build an application that can run on multiple servers, multiple versions, multiple targets, you had to build, package, and test the application in a very cumbersome way that was slow. Containers change all of that. You can build a container once, test it once, and then theoretically deploy that across different targets. That really accelerated the entire software delivery cycle. Organizations loved it. So the adoption started. Developers started using it. Not just developers, security people. Everyone started using containers. It was so simple. It was so easy. So if it was so easy and so simple, the question still remains, where are all the container breaches? So we kept asking the question, and we looked for more data about adoption. Are containers really used out there? And the data that you're seeing here from the CNCF 2022 annual survey, the best way to look at how successful something is to look at adoption. Are people really using it? And what you can see here is that most organizations adopted containers. 44% of them are running most or all their production applications as containerized applications. 35% of them, only some of the production applications, but they're in the journey to move entirely to using containers. The gist of it is that containers are widely adopted and widely used across organizations. So where are the breaches? What I'm going to cover today is that the breaches are here, but they look different. The second thing is that we need to remember that containers are about applications, and we're going to see how that plays a role in container breaches. The attack vector is very different. You can expect one thing, but what actually is happening in the wild is something completely different. And lastly is that the impact is very often understated. And this is part of the reason we don't hear more about container breaches in the news. So let's go back to square one. And let's see why containers are so different. What we used to do in the past is to really take an application and go and deploy that on a server, right? If you look at the right-hand side, this is kind of a very common thing. You have an hypervisor, you have a bunch of virtual machines that run a full-blown operating system, and on top of that, we ran applications. While containers really changed the paradigm. Containers are about packaging your application, including its dependencies, in a self-contained, lightweight construct that you can run on top of VMs. Now, the interesting thing about containers, outside of the fact they're lightweight, is that they're ephemeral. They're usually short-lived. What we see out there in the wild is usually containers run for a few minutes, most of them. And they're self-contained. One interesting aspect to keep in mind as we progress through the slides is that it's easier to scale containers. Now, the reason I'm mentioning that is, again, because that plays a role in the way breaches and attacks are happening in the wild. So keep that in mind. The second question we ask is, how people are using containers? What's inside the container? And again, on the left-hand side, you can see data that we collected across companies, across organizations. So containers are used for a wide range of things, all the way from running applications, of course. I have Go application, Java application. I'm going to containerize that. I'm going to run that in the wild, but also CI/CD pipelines. Again, what used to run on just servers, all of a sudden got containerized. So we have a CI/CD pipeline built out of containers that is used to build containers and ship containers, which is great. Microservices, of course, the development as a whole. Developers adopted containers to test their application locally on their laptop. Security people, right? Instead of going and deploying a very heavyweight scanner alongside application, now I can just spin up a lightweight container and I can do that. Containers got adopted everywhere, and they're using for a variety of things. But it's not enough to use the container, right? We need to operationalize it. If I want to take containerized application into production, I need to do a bunch of things. And this is a great example of a very common architecture you can see across organizations. It starts with a developer or DevOps that is creating a configuration file to build a container. They push this configuration file into a Git repository that then triggers a CI/CD pipeline that pulls this configuration file, build the application as a container, and pushes the artifact into a container registry. And then there is a GitOps pipeline to go and update the production environment with this newly created container image. Now, if you flip for a second and think about securing such a pipeline, do we even have visibility into those areas? If you think about a configuration file sitting on a developer laptop, is your security teams aware of the fact that that can be compromised? What about the registry? Do we have any telemetry coming from the registry? Do we know if there is a breach on the registry? And so on. Again, interesting aspect is that you can see containers in each and every step of this complex pipeline. In some of those steps, containers are actually being executed. So you have an execution of the containers in the pipeline. Very complex. Complexity leads to an increase of attack surface. We all know that, right? So what is this increased attack surface? This is a non-comprehensive list. You have the container operating system. Containers are packaging a subset of the operating system together with them, unlike hosts or virtual machines that have a full-blown operating system. What is this container operating system? Where did it come from? What do we do about it? The orchestrator, usually people are using Kubernetes out there to spin up containers in production. That's another point of failure, things that we need to pay attention to. Cloud services, right? A lot of us are using cloud services to run containers. That's another attack surface. The pipeline that I just showed you guys. Again, big attack surface. And supply chain as a whole. Think about third-party packages. Most of you are probably familiar with that problem. So an increased attack surface. What the security industry done to address this increase of attack surface is something interesting. They decided to create an acronym soup to confuse attackers out there. I'm half kidding. But really many point solutions were created to address the different aspects of the attack surface. I'm not going to go over all of it, but just starting from the bottom, initially there was the CWPP solutions, or the cloud workload protections, that really target vulnerabilities in containers and some aspect of runtime container detections, which was great. But then Kubernetes became a thing. People started running containers using Kubernetes. So we needed to have Kubernetes Security Posture Management, or KSPM, because configuration issues in Kubernetes means security issues. And that was not good enough because then people started running Kubernetes in the cloud. So cloud security posture management, or CSPM solution, really got expanded to address managed Kubernetes in some aspect of containers, and so on and so on. More and more and more point solutions, more tools, more data, more complexity. Fortunately, now we're trying to consolidate everything to a single thing called Cloud Native Application Protection. But generally speaking, those point solutions still exist. When you have so many point solutions in such a complex environment, detection, guys, is difficult. It's hard. It's hard. I mean, think about security teams. You have data coming from multiple new sources. They're not mature, new solutions. Those are not solutions that exist for 10, 15 years. This is not ADR. This is new. Do you have the SOC team even understand the data that's coming in? If you think about something that's happening in production environment, in a container, do you know how to associate a container with the right team? Who do you go and ask? It's very difficult. Do you have rules, detection rules, or alerts in your current solution? And if you get an alert, what do you know? Do you even know if you're compromised? And that is a big challenge with containers. Everyone adopted them very quickly. We created a bunch of complex operational structure to go and deploy them in production. We created a bunch of point security solutions to address security issues. And we left security behind. Security is having a really hard time to address that. There's also a very steep learning curve. Together with containers, the ecosystem evolved really quickly. Things like Docker files, YAMLs, EKS, Terraform, Kubernetes, CI/CD. Again, think about a security person that needs to learn all of that. This is not just security people, also the attackers. Attackers need to learn the same thing if they want to successfully attack those type of environments. The difference is that attackers only need to find one area that they can breach. They don't really need to learn the whole thing. And if they're in, it becomes very tricky to identify and detect them. So that was really interesting for us, going back to my story about what we've done at Sysdig. On one hand, we see great adoption and great complexity that got introduced into the system in order to operationalize containers. On the other hand, we don't see the breaches. What we also see is that security teams are not really aware of this new emerging environment that's moved really, really quickly and changes very rapidly. So we said, OK, let's see what's happening in the news. What happened in terms of container breaches up until that point? And this is just 3 examples, but believe me, there are not a lot more than what I'm showing here. Starting with Tesla. So Tesla got hacked. They had a Kubernetes environment that got exposed to the wild without a password, which was perfect. So someone identified that, hacked into the environment, immediately spun up a Bitcoin miner, but also stole a bunch of secrets. So that's what thing kind of a lightweight. OK, great. Weight Watchers, there was a research team that identified a Weight Watcher another Kubernetes cluster. This was open to the world. They went in and they identified customer data, real customer data. They approached Weight Watchers, and Weight Watchers said, it's nothing. You know, it's a dev environment, it's a test environment. Forget about it. It's OK. That's another thing kind of that reached the news. The last one was really interesting. CodeCove is a code coverage tool. A lot of developers are using that in order to identify how much coverage, testing coverage, they have across their code. And CodeCove released their application as a container out there. Anyone can download that, can use that. And what they forgot is that they baked a secret into this container. So they use a secret, and the attackers identified that secret. And that secret allowed them to reach an object storage that stored the script. And that script was a script that's used by thousands of organizations out there. So they went in, they modified the script to go and steal data and push it to their servers. Very interesting. That was very successful, but again, didn't make a lot of noise. No one heard about it, especially comparing to ransomware or DDoS attacks that you're hearing time and time again in the news. Huge impact, right? Very lightweight. And then we came up with a hypothesis about where are the container breaches. So the best way to think about where they are, or at least this was our assumption, is that we need to first go back and think about the attackers. What do attackers really after? And to figure out the evolution of cybercrime, we went back all the way to late 90s, the beginning of the 2000s. And you can see that if you're looking at phase 0, initially, it was all about ego-driven type attacks. People defaced websites. When you went to a website, you saw a bunch of kind of titles change and so on. It was fun. People made a name for themselves by doing that. Then we moved when Web 2.0 became a thing, and more applications got deployed into the cloud that are backed by a database. We saw more of the data theft. So people really tried to leverage SQL injections, for example, to go and steal data. They're really trying to really attack application weaknesses to go and steal data. Just developers' mistake to go and steal data. This is where the WAF, Web Application Firewall tools, became really successful because they defended against those type of attacks. Phase 2 is more recent, 2015, 16, 17. This is the ransomware. With the adoption of cryptocurrency, the attackers saw a path to money. All of a sudden, it was about a lot of money. And they could target sensitive organizations like hospitals, governments. And they could go and get money out of it in a way that make it not risk-free, but not a lot of risk, right? I can get the cryptos, I can run away, very difficult to go and go after me. And they started actually making real money out of this. The problem with that is that you're still exposed. You still need to interact with the person on the other side. You need to pick up the phone. You need to send an email, right? There is a paper trail that can lead someone to me. The other interesting thing is that cyber criminals became more like businesses, right? They started seeing the money. Immediately when you see the money, the next thing you think about is scale. How can I scale my operation? How can I make more money, right? It's not just about how can I make more money, how can I make more money with less risk? And this is where cloud comes into play. Now we have cloud. Everybody's scaling in the cloud, right? Deploying applications, containers, everything is scale, 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 scale. So the attackers, and that was our assumption, were also looking into that and saying, wait a second, how can we make more money by attacking companies deploying containers and applications in the cloud? And that was our assumption. This is what we're seeing right now, and it's just the initial steps. This is just a transition that is happening from a ransomware attack that is, again, high profit, but it still have risk, to something that it can make more money and actually lower the risk. Perfect. The second thing that we thought about, again, that was just a theory. We needed to prove that theory. Is we said, okay, if that is happening, is there really a transition from a ransomware to leveraging the cloud in order to really gain a lot of money, get a lot of money out of it, where are the attacks? And what we started kind of understanding is that the attacks are out there, and I'm going to show a few examples soon, but they're underestimated. The financial damages exist. Companies actually getting breached in the cloud and containers, but they pay a small amount of money. And usually cloud providers are just forgiving them. They're going out there and saying, oh, sorry, AWS, GCP, I got breached. Can you just spare me this 100K or whatever? And they're saying yes. The second thing is that the data theft that is happening due to container breaches is many, many times just overlooked, underestimated, or completely missed by security teams. So credentials are being stolen, intellectual property, and so on. No one knows about it. Or even if they know, again, they're downplaying the attack. Think about Weight Watcher, right? It's just a development environment. It's just a test environment, right? Nothing crazy. It's just a small exposure of customer data. Who cares? There's also an indirect impact. We're seeing service providers like not just the cloud providers, not just companies, GitHub, GitLab, any big service provider out there that are being attacked and impacted by that, but no one talks about it. Really interesting. Again, that was the theory. We saw bits and pieces of that, but we needed to prove that. Now we knew where to look, right? If it's about scale, if it's about mining Bitcoins, if it's about lowering the risk of getting exposed, then the attacks are probably going to be very, very different. So we started looking in a different place. And the first thing we've done is to come up with a way to actively scan every container image out there in public repositories, private repositories, you name it, we're pulling it in and scanning it. And this is data from our threat research report that got posted last year. And you can see here really interesting things. First of all, container images are a great place to hide. You know, what we've done at the beginning, if you remember the beginning of my story, that we spun up a bunch of vulnerable applications in the cloud, and we saw nothing, that was the reason. Attackers are not looking to go and attack your containerized application. What they're looking is to really bake their malicious code inside a container, so when you spin it up in your environment, they're already inside. Kind of a Trojan horse, if you wish. And we started seeing thousands of images that contains crypto miners, that contains all kind of malicious websites that you can access to, hacking tools. Many bits and pieces that show that attackers are full-blown invested in getting into your environment, just not through the proper way that people used to get into the environment in the past, through the application, but from within. The other interesting thing that we saw is that the pace of change. Every day, new images, new tools, new containers. How do we know that? We started looking in the wild on all kind of patterns, and then we say, wait a second, what is this file that is being used here? It's very strange. And we went back to the data here, and we saw thousands more images that contains this new file that we did not discover in the initial scan, because that's new, that's changed, right? So the pace of change is really rapid. That's another really interesting attack that was super sophisticated. And the reason that I'm mentioning that is because it's slightly different than what I told you guys so far. We're calling it Scarlet Eel, which is a very interesting name. And that was kind of the common lateral movement in the cloud. What we had here is an application that got breached in the cloud, containerized application. And the attacker really quickly was able to go into the cloud and really escape the container, go into the host, and immediately spun up a crypto miner. The second thing that I've done is to identify a lot of secrets around the environment that help them laterally move to a new cloud account, and again, try and get more and more sensitive data. The reason I'm mentioning that is because it's not that all the containers attacks became a supply chain attacks or more of a Trojan horse. Some of them still happen because of remote code execution. So that's the first takeaway. The second takeaway is that it happens really quickly. Time in the cloud is critical. You don't get a lot of time to detect. You don't get a lot of time to address those attacks. It happens quickly. They spin up Bitcoin miner. They steal your money very quickly. They can spin up thousands of very expensive compute instances to mine Bitcoin miners. They take them down. And if you're lucky, you know about it. If you're not lucky, you're going to get the bill, and someone's going to foot that bill, either you or the cloud provider. Another attack that we saw in the wild, a very sophisticated one, call it Purple Origin. And what they've done here is to really try and attack all the service providers that provide free tier compute, things like GitHub Actions. Anyone that allows you to spin up any compute in the world for free, they try and attack that. The second interesting point is that the way they attack those service providers is by using containers. So they operationalize the entire thing using containers. And this is what we detected in the wild, again, using our active container scanning mechanism. All of a sudden, we saw this interesting thing, containers with thousands of layers between them. So active development of this free jacking operation that went and really stole money from organizations. Some call it pilfering, stealing small amounts from many amount of organizations. And it's exactly what happened here. It's a really interesting operation. So what some of the takeaways that we have? So first of all, we need to consider the impact. The attacks are happening, but it's not what you're expecting. it's unlikely that you're going to see your containerized application running in a kube cluster in the cloud, getting a direct attack by something like a SQL injection, remote code execution. It might happen for sure, yes, Log4j, I know. But most likely is that you're going to see attackers trying to insert themselves through a package or maybe a malicious container. Maybe they're going to hack one of the developer machine to change the source code or the configuration file so they can immediately find themselves within the environment. You have to really go and investigate the incidents. It's very difficult to identify them. So you need the right tools in place, and you need the right manpower. You have to encourage collaboration. We talked about it, how difficult it is for security people to really figure out what's happening in the environment. So what do we do about it? We're trying to get security and engineering closer. What is this namespace? What is this container? They need to work very closely with development, with infra, to figure that out, to really accelerate the pace of investigation and identifying the issues. You have to improve visibility. You can scan for vulnerabilities, but then you identify the known knowns. What we saw is that constantly attackers are changing what they bake inside the containers and how they go about containers attacks. So it's not enough. Supply chain needs to be an essential part of your security. There is no way you don't have any supply chain security in modern environments, because this is what attackers are looking for. And runtime visibility. Again, you can scan for known things. It's the same problem we had with antiviruses in the past. When you have signatures, great, you need to have that. But what happens when something changes? You need to look at behavior. Eventually, all attackers, no matter what they do, they need to run something in your environment that doesn't go away. Your last line of defense is runtime visibility. Don't give up on that. To summarize, containers are everywhere. It may seem like there are no containers attacks, but they're actually happening. The traditional attack vector is not always applicable. Again, if you're looking at applications in the cloud, they have weaknesses, you have configuration issues, that's great, go and solve them. But containers attacks look slightly different. It's more supply chain. And this is what attackers are trying to do. They're trying to get into your developer's laptop. They're trying to hack into your registries. They're trying to post malicious packages out there, malicious containers, so someone mistakenly can pick them up and they can spin up their stuff inside your environment. Attackers also adopted containers. It's a great vehicle, right? Why not? Then I'm going to use containers in order to launch my attacks. And again, runtime visibility is vital. That's it, guys. Thank you. Any questions? Perfect. Appreciate it.